So you guys, we could, how many people are over graphing? Over it, agreed. So we're not going to practice it much because it's really not that efficient. You guys, let's go graph to find where these two lines intersect. What are we going to do first over here? Let's get that y, yeah, slope-intercept form. Let's get that y by itself. Do you want to subtract 3x or add 2y? I don't care. Okay, so we got negative 2y is negative 3x minus 5. What's my y equal to? Positive or negative 3 halves? Positive 3 halves x plus or minus 2.5? 5 halves, same as 2.5? You cool with that? Great. Let's go do the other one too. Y would equal what on the right side? Beautiful. Thanks, Mateo. So you guys, we got to go graph these. And again, graphing something as a half, gross. If we go up 2.5, did I do that right? Up 2.5? Boom. And my slope is up 3 over 2 or down 3 left 2. Down 3 left 2. Let's go connect those dots with your nice little ruler. Oh gosh, can I do this straight? Let's see. Okay, I got that straight line drawn in. What about negative x minus 2? Do you guys agree when you draw this in, do they cross at a nice point?
No.
No. So are we able to figure out where their solution, oh no, where the solution is? Like perfectly? I have no idea, right? So graphing is not a great option when if we don't get it on a perfect coordinate. You know what I mean? So over here, and I wish it would all stay together, but of course it's not. Darn it. You think I can get that to stay together? Lock it. Lock it. Yes, look at that. Okay. So our solution, we might be like, I don't know. What would be our guess? Anyone have a guess what that solution would be? Negative
1.75.
Sure. Negative
0.25.
0.25. Do we feel okay with that guess? But the big thing is, you guys, unless it's on a perfect coordinate, graphing is not helpful because we are literally just guessing. I was like, sure, Coop, maybe, I don't know, right? So we are really not going to use graphing this unit. Can it be helpful if they cross at a perfect point? Sure. Something I'm not going to ask you to memorize this vocab ever is something being consistent versus inconsistent. But you guys, basically what I want us to focus on with these pictures is how many solutions do these two lines have when they cross here? Whoops. How many solutions? One solution. So I just really want us to focus on that one solution part. That's all I really care about. You guys, these two lines, this word, coincide, right? 2 times, these two lines are going to get me the exact same line. So they are coinciding. And how many solutions if one line lies right on top of the other line? How many times do they intersect? Infinitely many solutions. When one line is the exact same as the other. And how would I have no solution? What do my lines have to be for no solution? They have to be parallel, meaning the whats have to be the same. The slopes have to be the same. This would get us no solution. Cheerio. So let's do something a little bit more accurate, shall we? Let's remind ourselves what the heck this elimination method is. You would have seen this for the first time in Algebra 1. You saw it again with Mr. Richards down, and I personally love elimination. Okay, elimination means that you need to eliminate a variable. I don't care which variable you do, but you need to eliminate. Hey, Rye Guy, would you rather eliminate your x's or would you rather eliminate your y's? Doesn't bother me one bit. You just tell me what you would prefer.
I feel like I would prefer to get rid of the x's.
Okay, how? And how we all do this? Every single person in this room could complete this differently and still get it done right. Is one way going to be faster than another? Sure, but we can still all do it different ways. If we chose x's, don't write this down. If we chose to eliminate x's, what would I need to multiply this first, or what could I multiply this first equation by?
3.
You're saying, and don't write this down, people. Don't write this down. If I multiplied this first equation by 3, What would I get, Mr. Mateo? 15x plus
6y.
equals 1,020 maybe-ish. I'm not correct because we aren't writing this down, okay? If I multiplied this by 3, what would I want to multiply this one by to eliminate my x's? Eliminate. You said negative. I love that you said negative because you're thinking negative 5 multiplied through would get me a negative 15x plus a 20y. Guess what everyone forgets? To take it to the third thing is negative, I don't know, 16, don't care. If I added these together, you guys, do those eliminate? Yes, then I'd get 26y equals whatever these add together, and I'd have y solved for. Done. Ryan, great method. Why do I not want you to write that one down? Because we had to multiply both functions by something, which is fine. Is there a way that we could only multiply one function by something?
Yeah, the first one by 2.
If I, could I get my y's by itself? Which one are we saying multiply by 2? The first one or the second one? First one. Do I want to do positive 2 or negative 2? Because that one's already negative. Great, Ritzy. So if I were you guys, ready, Beck? If I were you guys, I'd throw a 2 out front just so we can see it. I would throw my little distributing arrows because we got to remember to go to that third value. And if I were you, I'd put my work right over there. What is 2 times 5x? 10x. What is 2 times 2y? Plus 4y. What is 2 times 340? Beautiful. I put them just because I didn't want to rewrite the whole thing. Then you guys, would we add or subtract them for my y's to cancel out? Negative 4y plus 4y would cancel out, right? I wouldn't want to do negative 4y minus a 4y. They wouldn't cancel. So you guys, I like to say, all right, 3x plus 10x is how much? 13x. Then I go like this. Well, negative 4y plus 4y, they gone. 680 plus 360.
140.
1040?
Yep.
Cool. Divide by 13? Does that go in nicely?
Yeah, it's 80.
Wow, we love that. We just found where these two graphs intersect is when x is 80. Would you have liked to do that by hand and graph it and find an x coordinate of 80? No, our graph would have had to be huge, right? You guys, if x is 80, how would I go find my y? Do I have to plug it into my first function, or do I have to plug it into my second function, or does it not matter at all? Doesn't matter at all. You guys, I'm going to go plug it in over here, and I'm only choosing that because I've got space right here. That's where I am. So I'd say, all right, what is 5 times 80 plus 2y equals 340? You could have totally bypassed that and gone straight to 5 times 80 is how much? 400. Thank you, buddy. 2y equals negative. Great. Y equals? Beautiful. What you've just found is where these two graphs intersect at this coordinate. We want to write it as a coordinate. What's my x comma y? 80 is my x. My y is negative 30. You guys will always write them like that. The x always comes first. Boom, 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 boom. There's where they intersect. Let's try it again. Again, you guys, sometimes we got to think really hard. We got to guess and check some things. And maybe we use our calculator to help ourselves, and that's fine. What do we want to multiply by what? Do we want to get rid of our x's? What could I multiply 1.5 and 2.5 by? Different numbers, that's fine, to cancel out. Maybe you're like, decimals kind of scare me. Can we focus on the y's instead?
Yes.
Which one do we want to do? Because again, we can do any of them, right? Livingston Sanders is? Which one would you guys rather do? Why? We're doing the why? Okay. What are we going to multiply my y's by for one of them to eliminate?
5 and
Oh, snap.
2.
You're saying 2 times 2.5 gets me negative 5. Or yeah, I think you said negative 2.5. Yes. Is Biscuit right?
Yeah.
How many people didn't think of that method? I didn't, because I don't want to multiply a decimal throughout. Can you? Absolutely. Biscuit, I challenge you. Go do 2.5. You're going to get the right answer. But you might need your calculator involved, and that's fine. So Biscuit, you go do it. You're going to get it. I just don't like decimals as much. If anyone else doesn't like decimals, stay on my team.
Sick.
Cooper, what do you want to multiply by?
5 and negative and 5 and 2.
You're saying, I just want to deal with whole numbers,
Yes.
and I want to get my y's to cancel. How we feel with that? Yeah? Yeah? Ooh, but then to Biscuit's point, I still have a 5 times a 1.5. Like, regardless, we've got decimals anyway. So,
It'll add up to be a whole number when
exactly. But even if we're using our calculator for that, you guys, we're okay. 5 times 1.5, what are we going to get? 7.5x plus, how many y is there? 10y equals 100. Now, when I go distribute my 2, I'm going to put it right down here so I don't have to keep writing it. 2 times 2.5, 5, minus 10y, thanks, bud. I'm sorry, 5x, yeah. Equals negative 50. Does my y's eliminate? Do my y's eliminate?
yes.
10y, negative 10y, they're gone. What is 7.5x plus 5x's? 12.5x's equal 50. 50 divided by 12.5 comes out nicely. Biscuit. Okay, so if x is 4, you guys, do we have to plug it in right here? Do I have to plug it in right there? I don't care which one we plug it into, you guys. Let's go plug it in. Which one do we want? I don't care.
I'd say the all positive one.
Oh, all positive. That's a great way to think of it. All right. If I plugged in 1.5 times 4 plus a 2y is 20. 1.5 4 times gets me 6. Did you get y is 7?
I did.
Yeah, x is 4, y is 7. We're done. I want you to take what I want you to take away from this. There are infinite ways for you to solve this. Macy could have chosen completely different numbers, still got the right answer. Okay? Doesn't matter what you choose. As long as they work out, we will all get the same answer. Okay? Substitution is helpful, especially in a certain case. Why does this lend itself to substitution? Will there be a new tight end in Luke Lachey's spot this weekend?
Yeah.
He had to be substituted out because he broke his ankle. Someone's going to take his spot. What can 3x minus 8 take the spot of? Y. Boom. It can take that spot. Why is this helpful for substitution? Because my y was already by itself. If there's a variable by itself, substitution is very helpful. So I'm going to go plug that in right there. And I've got 2x. Instead of y, instead of Luke Lachey, what are we putting into that spot? You got it. Equals 22. So we took care of this whole second equation. Instead of y, I got to put in 3x minus 8. Let's combine some like terms. 2x and 3x.
5x.
Minus 8 is? Good. 5x equals 30x's. Good. If x is 6, is there one way in this one that would be easier, one equation to plug back into? Where the y is already by itself, right? Again, we can plug it into the other one. It's just going to take an extra step. So my y would equal 3 times 6 minus 8. Final answer? Great. The point where these intersect is what? 6, 10. Done. Okay. This last one. Could you do elimination on this?
Yeah.
Sure. I just want us to practice substitution one more time. You can do elimination, though, to solve any of these. How would I substitute if I don't have a variable by itself?
You create the equation.
Sure. Could I get an extra y by itself over here?
Yeah.
Is it going to be miserable?
Yes.
We're going to have fractions and everything involved. Gross. Is getting one of these x's and y's by itself easy? Yeah. Which one would you rather? I'd get x by itself because then we'd have all positives, right, Beck? So x equals, how would I get x by itself? Y plus 2. I'm going to take that y plus 2 and I'm going to throw it into x right there. What do we need to be careful of? Say it again. We got to multiply by 2, but would that look like this? What am I missing? I'll put parentheses because I think what word I was looking for was you've got to distribute that 2. You know what I'm saying? So please don't forget those parentheses when you plug them in. What do we get when we distribute that? 2y plus
3y.
Equals 2y plus 3y
5y.
equals. Nice. Subtract that 4. You cool if I do that all in one step? Ooh, what does y equal? Positive or negative? Wouldn't it be positive? Because 8 minus 4 was positive. It's cool. It's cool. So you guys, this would be one that would be nasty to have to graph, right? I don't know when my y is 4/5. Which one are we doing plugging y into as 4/5 into? Yeah, I'm actually going to plug it into my original just in case I made a mistake. I'm going to plug it in right there. Boop. So I'd have x minus 4/5 equals 2. Add 4/5. 2 plus 4/5.
2 and 4/5.
2 and 4/5 is the same as, because I'm not going to use any mixed numbers this whole year. What would be that the same as? 2.8, true. Let's go improper fraction.
Oh.
You always, you multiply, then you add. So what's 2 times 5? 10 plus 4? Now, if you're like, dude, that is like 4th grade math. You guys, you could have always done 2 plus 4/5 in your calculator, math, enter, and bam, it'll give you the 4/5. Okay, 14/5 will come up as soon as you do that math, enter. What's my solution here, you guys? What's my x? Y? Thanks, buddy. Last question. This is a lot of words, but this is actually very real worldy. It says, hey, Madison's getting a car for 2 years, leasing a car. The dealership says they will lease her the car she has chosen for $326 a month by only putting $200 down. You only have to give the car dealership $200. You walk away, and then every month you owe $326. However, if she puts $1,600 down, she might not have that, but if she does, her lease payment is only $226 a month. Saves $100 a month. What is the break-even point? When does it matter? Which 2-year lease should she choose if her down payment is not a problem? Like if she has $1,600 cash, does it save her money in a 2-year lease? So here's what I want to ask you. Let's try to write an equation talking about the first one where she is paying $326 a month and $200 down. How can we put that in a little y equals mx plus b? What's my slope? Yeah.
It would be 326.
Yeah.
X plus 200.
Exactly. That's saying $326 every month plus this much down. That's just a one-time fee. What's my other equation going to be when it was $226 a month but $1,600 down? Good. Don't forget that X with your 226. Perfect. You guys, you can do substitution or elimination. Doesn't bother me one bit. Which one would you rather do? I got a y by itself. Beck's like, if y equals this, couldn't I plug that boop right there? I think that's a great strategy. So we got 326x plus 200 equals 226x plus 1600. So if we move some x's around, I've got 100x equals 1400.
Yeah.
X equals 14. Now, what the heck does that even mean? Close. Don't forget our x's, we're talking 326 per month. So this is at 14 months. Can we figure out how much we'd pay? Where could I plug that in to figure out how much we'd pay after 14 months?
Easy plugging it back in.
Could I plug it in here or there? Yeah, it doesn't matter. Go plug it in, you guys. What would plugging in 14 there get me? Either one. It's going to get you the same thing.
The first one is 4764.
4764? Great. Try it in the second one. Dare ya. Perfect, right? So, you guys, regardless of which lease option she chooses, 14 months in, she will have paid $4,764. Does she still have time on her lease?
Yes.
So doesn't she still have 10 more months, right? Because 24 months in 2 years. So if you are paying the same amount up to 14 months, would you want to keep paying $326 a month or $226 a month? When you want to pay $220, save yourself $100 a month.
Well, it's a 2-year lease.
Correct.
So, you got to check the prices of both options.
Right. But are we going to be saving $100 a month after anything after 14 months if we choose this option? So you guys, we're going to want to choose this option. $226 a month. Will save her the money.